Alright, in this video we're going to start to talk about collisions. So in the last video we talked about explosions and the fact that momentum was conserved. Now we're going to talk about when two objects actually run into one another. So in this video, let's just address the idea of a perfectly elastic collision. A perfectly elastic collision is one where momentum is conserved, of course, because it is always conserved, but also kinetic energy is conserved. And typically in an elastic collision, things are bouncing off one another. But just because two objects bounce off one another does not mean that they are perfectly elastic collisions. It is only when kinetic energy is conserved. So we're going to do an example of this type of problem, and then we'll go back and we'll check the kinetic energy and figure out if the collision is perfectly elastic or if there is some loss in kinetic energy. So let's say that we have a cart, and it's 1.6 kilograms, and it's moving to the right with a velocity of 5.5 meters per second. And then we have another cart that's moving along, and let's say that cart's 2.4 kilograms, and it's also moving to the right with a velocity of 2.5 meters per second. All right? So this cart is moving faster, so it's going to eventually catch up and run into this cart, and they're going to bounce off one another. And after the collision happens, so this is before, so after the collision happens, now we have this 1.6 kilogram mass, and it has bumped into the other one, and it is now going only 1.9 meters per second. And then this guy here is going 4.9 meters per second. Okay, so let's go ahead and see, is this a perfectly elastic collision? So in order for this to be a perfectly elastic collision, all the kinetic energy at the beginning has to equal all of the kinetic energy at the end or after the collision happens. So you're going to have your before side of the equation, and you're going to have your after side of the equation. Okay, so I have this object going this velocity, so its kinetic energy would be 1/2 mv squared, so 1/2 1.6 5.5 squared, plus 1/2 and then 2.4 and then 2.5 squared. Then our after scenario, we have the 1.6 kilogram with a kinetic energy of this, plus this guy, his kinetic energy is 2.4 and then 4.9 squared. So if I just type that in, 0.5 times 1.6 times 5.5 squared equals 24.2 for this one. And then I get 7.5 for this one, so we'll add those two together, and I get 31.7 joules to start with here. And then let's go over here and see what we have there. So 0.5 times 1.6 times 1.9 squared, and then that's 2.888, and 0.5 times 2.4 times 4.9 squared gives me 28.82. So over here I get 31.7 joules. 28.8182 or something like that. So you can see that this is a perfectly elastic collision because the kinetic energy at the beginning is equal to the kinetic energy at the end. Now, we can use this idea of momentum in order to look at an elastic collision and figure out what the velocity at the end would be. So let's just come up with a scenario. So let's say I have one car, and it's moving to the right, and let's say it's 2 kilograms, and it's moving to the right at 4 meters per second. And then I have another car here, and it's moving to the left at 1.5 meters per second, and let's say it's 4.5 kilograms. Now, once they run into each other, we're going to have this car is actually going to bounce back in the other direction. Oh, let me get the lights back on. it's going to bounce back in the other direction. And let's say that it's going to go this direction, and it's going to be like 0.5 meters per second. And we want to know what is happening with this car. Okay, so again, we're just going to use the idea of conservation of momentum. So this is the before, and this is the after. So before part of the problem, and then the after part of the problem, and then we have equal sign in between. So before, the momentum would be 4 times 2, or m times v. Okay, and then over here, we're actually going to have negative because it's going to the left. Right? And then over here, we have this guy going 2 kilograms is now also negative 0.5 meters per second because it's going to the left. And we have the mass of this guy, and we want to know what is his final velocity. Right? So 4 times 2 is 8. 4.5 times 1.5 is 6.75. So we get 8. And then minus 6.75, so the 1.25 over here is equal to 2 times a negative 1/2 would be negative 1 plus 4.5 v. So we would add this over here. We get 2.25 equals 4.5 v. And I get 0.5. So this guy is, let me just, yeah, that's right. So the velocity of this one is equal to 0.5 meters per second. So he would be going this direction in 0.5, oops, sorry, he would be going positive this direction at 0.5 meters per second. Okay? So we can use the idea of conservation of energy, or conservation of momentum, in order to solve when two things bounce off one another. But we have to remember that if we are going to say that a collision is perfectly elastic, then it has to be the scenario where kinetic energy is conserved.